appreciation before, which was when it was a basic question and it told us that we were increasing by 4.5%, or we were decreasing by 20%. And we always did our final, our initial, we would add our interest rate to the number of years, correct? Compound interest is very similar to the appreciation formula. On diplomas, they'll often, if they do give you a formula, they will give you A equals P 1 plus I to the n. That's how they'll give it to you. If we base it off of yesterday, it'd be like final equals initial. 1 plus interest rate to the n. Similar formula, right? Basically the exact same, yes? The only catch is this has the word compounded in it. What the heck is compounded? Well, simple interest is very simple, actually. It's actually labeled quite correctly. Simple interest, you basically, if you put something in for simple interest, at the end of the term, it would just take the amount you had, get you the interest, poof, done. That's it. Okay? You just have a flat rate of interest. Simple interest is not great if you want to make money faster, though. You want compound interest. Compound interest, what it does is, after X amount of months or days, it takes whatever interest you made off of it, and it puts it in with the amount of money you invested, and now that next term, you're making money off of the money you put in plus the interest. So you actually make interest off your interest. So it grows faster, okay? If you were taking out a loan, you'd prefer it to not be compounded because they're making interest off the interest, right? So mortgages are compounded semi-annually, which is twice a year. They can't do it any more than that in Canada. So every 6 months, whatever you have left to pay on your mortgage, they calculate the interest on that, and it gets put in with your principal. So that's why it takes so much time to pay off a mortgage. Often a 25-year mortgage at like 5%, which seems really low, you're paying double. So if your house was worth $400,000, you probably paid $800,000 for that house at the end of your 25-year term. Because it compounds, you're paying interest off your interest. For the first half of the time, you're mainly, at the very first few years, you're mainly paying interest. You're not even paying off principal. You're paying very little off principal. And then towards the end, you're paying more principal than interest. So it flip-flops. The key thing with compounding interest, though, is if you compound semi-annually, at 6 months, you're going to figure out the interest you have to pay, right? So you're going to have to take the total interest and divide it by 2, because it's going to be every 6 months or every 2 times in a year. So let's talk about compounding. So if it says it compounds, let's say annually, CP would be, your compound periods would be once. So once a year, it will compound. At the end of the year, you take your interest that you make, you put it in, and the next year you make principal, or money off the principal, what you put in, and the interest. Okay? So it'll be once a year. It's per year. Quarterly, how many times per year do you think that is? 4. Yeah. So basically every 3 months, I would calculate the interest, it would go in with what I put in, and then I'd make that off the next time. Reminder to you, these are your notes, you should fill them in. Okay. Semi-annually. Semi-annually is how many times? 2. Every 6 months. And then what about monthly? What do you think that's going to be? 12. So if it was just your basic, it was increasing by this much and it wasn't compounding, bless you, you would add your interest rate to it, you put your number of years, you'd be golden. However, this is compounding. So we have to watch ourselves. Our interest per year, we actually have to find our interest per compounding period to put in for I. And then our N, our number of years, we actually have to find how many times it compounds. So let's say it was for 10 years and it compounded semi-annually. How long would that be then? 20. It would be 20 compounding periods, right? 2 times a year for 10 years, 20 compounding periods. So when we use this formula, we are actually dividing the I by the compounding periods because we have to find the interest per compounding period. And our N is being multiplied by compounding periods because we have to know the total number of them. So that's important. The formula they give you, if they do give you one, won't have the CP's in it. It's just going to say I is interest per compounding period. So you're going to need to know that you're dividing those out. And they'll say N is number of compounding periods, not years, right? So then you have to times it. So let's look at this first one. You invest $500. So is that initial or final? Initial. You're walking into the bank and you hand them $500. Okay? So we know our initial is 500. And it pays 6% per annum. Remember, per annum just means per year. It's always going to be per annum or per year. Thank them for that because it gets way more complicated if it's not. What is 6% as a decimal? 0.06. So our little I didn't change. It's still 0.06. It compounds semi-annually. So what's our CP? 2. They just want us to write an equation. We're not solving anything else because we don't know N and we don't know F, correct? And if we don't know more than one thing, we can just set up an equation. So we don't know N and we don't know F. Okay, so let's set it up. Final equals 500 bracket 1 plus, what's my I? 0.06. But I have to remember because it's compounded semi-annually, I'm actually taking that answer and dividing it by 2 because I need the interest per compounding period. So every 6 months it's increasing by 3% because in the whole year it's increasing by 6%. Make sense? And then we don't know N, and we have to times it by what? 2. So let's make it look a little nicer. F equals 500, and then 0.06 divided by 2 is 0.03 plus 1. So I get 1.03 to N. You know what I'm saying? Does that make sense? Some people are like, I don't know when it's a compounding question. Very easy. What word is in the question? Compounded. Hello. This is one of the easier ones, right? The other ones are a little harder to decipher which of the ones they're asking, but this one says compounded in it, so it screams compounding. Okay? All right. So here we need to estimate the value after 5 years. So what are we going to plug in there? Yeah. So our F is what we're solving for, and we now know our N is 5. So we're going to get 500 bracket 1.03, and then 2 times 5, which is 10. Everyone's typing it in. Writing it out, because I want to see if you actually get the right answer. Some people type these in wrong. So I get 671.96. Now, if I ask you how much interest she made, she didn't make that much interest, right? She walked into the bank with $500. She came out with 671.96. So she made 171.96 in interest, right? Because you take that value and subtract off the 500 she walked into the bank. Okay? Okay, this one says, determine when you would expect your investment to double. So now we're looking for N. Your investment to double, what did they give us? Our final is 1,000. So I'm going to do this one down here. I need the room. So, 1C. So I get 1,000, my final, equals my initial, which is 500. And then my formula is 1.03 to the 2n. Now what did I tell you to do always when you have final and initial? Divide it over every single time. Take that initial and divide it over every time you have both. And divide by 500. And we get 2 equals 1.03 to the 2a. And then we're going to do what to it? Make it a log. So we get log base, what? 1.03. And then what friends doesn't stay friends, what do I get? 2 equals 2n. And then I need n by itself, so I'm going to divide by 2. Remember, everyone's typing it in. Let's see what's round 2. I'm going to round 3 years 10. 11.7 years. I want you guys to try 2 and 3. Okay, then 6-year GIC. What's that? N is 6. Compounded quarterly. What's that? CP equals 4. A rate of 5% per annum. What's that? Little I is 0.05. You can always take the number and divide it by 100. Right? Determine the value of the investment at the end of the term. What are they asking us to find? The final, the F. So we have F equals 7,000 bracket 1 plus 0.05 divided by 4 to find out the interest per compounding period, and then 6 times 4. 0.05 divided by 4, I believe 0.125. So we're going to get 7,000 bracket 1.0125 to the 24. Is this number going to be bigger or smaller? Bigger. What if it's smaller?
It's messed up.
You messed up. So it is 9,431.46. And you should have a sentence when it's written response. Okay, 3. Let's discuss this one. So this one wants us to find the interest rate, which is little I, per annum to 1 decimal place. Which $3,000 investment, so capital I. Compounded quarterly, CP of 4. Will double over the value of 5 years. So double means my final is 6,000. And then N is 5 years. Okay. Everyone following along? Because I'm not going to repeat the calculator except when you're lost. Alright. So we get 6,000 equals 3,000. Bracket 1 plus I divided by 4 to the 5. I told you when you have your initial and final, the first thing you're going to do is divide it over. We're going to divide by 3,000. And we get 2 equals, 5 times 4. 2 equals 1 plus I divided by 4 to the 20. Now the first thing we have to get rid of is the 20. If it was a 2, we'd square root. If it was a 3, we'd cube root. Since it's a 20, we're 20th rooted. You guys need to pay attention. So we're going to take the 20th root. And we're going to leave it like that for now. So we're going to go to the 20th root of 2 equals 1 plus I divided by 4. Shh, you guys aren't paying attention. So, I'm not going to put the 20th root of 2 in right now because it's going to be a crazy decimal, correct? And I want to keep all my decimals until the very end. So I'm going to go 20th root of 2, and then I'm going to subtract 1. And I'm going to write that. So I'm going to go the 20th root of 2 minus 1 equals I divided by 4. Do you see how that minus 1 is not under the square root? It's going to be the 20th root of 2. Get an answer. I'm going to subtract 1. Get an answer, and then how do I get I by itself? It's divided by 4. Times by 4. So I equals. So, how do we punch this into our calculator? You go 20, math, number 5. Everyone's following along. Your calculator. 20, math, number 5. Because it goes in for that x. Do you see that? 2. Enter. Then what am I going to do? Minus 1. Enter. Then what am I going to do? Times it by 4. Enter. And so I get 0.14105. This one just says the interest rate per annum. Does it say? And it says to one decimal place. So this would be 0.1. Now, if it says interest rate per annum to the nearest one decimal place or nearest tenth of a percent, changing it up here. If it said, or write this down here, nearest tenth of a percent, what am I going to have to do first before I round? Change it to percent. How do I do that? Times it by 100. So I'm going to get 14.1%. Very different answers depending on what they ask you for. If they just want the interest rate to nearest tenth, you just nearest tenth it. If they want it as a percent, you times it by 100 then. Okay? Then we're going to move up to the very top. Doubling, tripling, half-life. This is our third type. Everyone paying attention? New formula. All right. So, if I have the original amount, what percentage do I have? I have 100%, correct? If it's doubling, what percent do we have? 200%. What is that as a decimal? 2. If it triples, I have 1%. 300%. What's that as a decimal? If it halves, what do I have? 50%. What's that as a decimal? 0.5. So let's keep that in mind here. So the formula we can use for half doubling and tripling is still final equals initial. And then I put an R to the T over P. You can put the R as whatever you want. The key thing is the R is a number once you apply it to 100. So if it doubles, what is my R? If it doubles, what's my R? 2. If it triples, what's my R? 3. If it halves, what's my R? 0.5. So let's write that at the top. My R changes depending on what it's doing. These ones won't give me interest rates. They'll tell me that it's doubling, tripling, or half. So R equals 2 if it's doubling because it's at 200%. R equals 3 if it's tripling because it's at 300%. And R equals 0.5, or we could put in a half. They're the same thing. If it is a half-life. Okay, you spot them because these questions don't have a percentage. There won't be like this percent per annum. So that's how you know they're these ones. They don't have a percentage in them. They also have the words doubling, tripling, half-life. Now, the other thing that people get really stuck on is the T and the P. Okay? T is time to reach final. Do you see how the T is on the top and the arrow doesn't have to cross over? It just goes straight to F. T is time to reach final. So if they say in 30 minutes I now have 700 bacteria, 30 minutes would go in T. Okay? Time to reach final. P is the period. How long it takes to repeat. So if it has a half-life of 40 minutes, that means every 40 minutes, whatever it is halving. Every 40 minutes, halving. Or if it doubles every 3 hours. If it doubles every 3 hours I'm having double it. That's the period. How do you know they gave you the period? Because it's the time that comes right after the word double. Doubles every 30 minutes. Halves every 40 seconds. So it comes right after the word double, triple, or half. How do you know they're asking for the period? Half, double, or triple is in the question at the very end of the word problem. It'll say, how long does it take to half? How long does it take to double? How long does it take to triple? Okay, the tripling time or the half-life is. Okay, so let's go through and see if we know what we have. So a lab tech plates a bacterial cell. A bacterial cell, where's that going? Initial. So the initial is 1. Make sure we're writing this down. Initial is 1. Into a vial at 5 a.m. The cell divides in such a way that the number of cells doubles. What's that? R is 2. Doubles every 4 minutes. So every 4 minutes this thing is doubling. Is that time to final or the period? It's the period. The key thing as well is if P is in minutes, T has to be in minutes. They have to be the same unit. Okay? All right. How long does it take? So how long does it take the cells to divide to produce 4,096 cells? So what did they give me? And what are they asking me for? T. Right? So they're asking me for the exponent. I'm going to be missing the exponent. So I'm going to have to convert to a log. Every time I'm missing the exponent, I convert to a log. Every time there's a variable in the exponent, I convert to a log. Okay? So, let's fill this in. Our final is 4,096 equals 1, bracket 2 to the T divided by 4. I have my initial and I have my final. What am I going to do? Divide it over. When I divide by 1, it really does nothing, but it gets rid of the 1. So I'm going to get 4,096 equals 2 to the T divided by 4. Now this one I could actually make common base and solve it that way. Make them both be base 2, which we talked about before. Or I can do what? Convert to a log. The moment I don't know the exponent is in the variables in the exponent, I have to convert. So I'm going to get log base what? Log base 2 of 4,096 equals T divided by 4. And how do I get rid of the division of 4? Should be getting 48 what? Minutes. Two, three, four, five, go. So 2 says a radioactive isotope has a half-life of 7 years. Half-life 7 years. So half-life, and then the amount comes right after it. So what did they give me? P or T? P. If it comes right after the word half-life, doubling, or tripling, they give me P, right? It halves every 7 years. So my R is 0.5. The P is 7. Determine how much of the isotope must be initially present. So they're asking me for I. In order for it to decay to 60 grams, final is 60 grams, in 14 years. So then my T is 14 years. Okay, so you're going to have 60 equals I bracket 0.5 to the T over P, 14 over 7. This is extremely easy, and you guys get stuck because if I give you an awful one that you have to convert to a log, you guys are like, I got this. If I give you one where you just have to divide something, you're like, I have no idea what to do. It's gone. So this is 60 equals I times 0.5 to the 2, correct? Technically? I need I to be by itself. It is being multiplied by 0.5 to the 2. So what do I have to do to move that over? Divide it. That's it. So I should equal 240 grams. All right. Makes sense when you're missing I, you literally just divide it. So I used to only show the ones where you were missing the exponent because I was like, everything else everyone can just do. And then I realized, no, you guys think at the easy ones and you guys rock at the hard ones. It's the strangest. Okay? So let's look at the next one. What is the half-life of plutonium-232? Which is nice, no, we don't care. What is the half-life? It's in the question. What is the half-life? So R is 0.5, and what are they asking me to find? Period. So remember, if half-life doubling or tripling is in the question, they're looking for the period. So what is the half-life of plutonium-232? If in 204 minutes it decays to 1/64th of its original. So this one is a little bit harder. People get stuck on this one because they don't actually give you the original. I just say it's 1/64th of it. So time to reach final is 204 minutes. My initial can be whatever the heck I want. It can be 100, it can be 64, it can be 2, it can be 7.6, it can be whatever you want. The final just needs to be 1/64th of it. Okay? So the easiest thing to make your initial be is 1. And then your final is 1/64th of 1, which is 1/64th. If you make your final be 100, you're going to have to times it by 1/64, and then that'll be your final. If you made your initial be 6.7, you'd have to times that by 1/64 and make that be your final. Hence why picking 6.7 would not be a good idea, right? So then we have 1/64 equals 1, 0.5 to the 204 over P. Divide my 1 over, and I get 1/64 equals 0.5 to the 204 over P. And now I'm missing my exponent. My variable's in my exponent. So what am I going to have to do? Convert it to a log every time. So we get log base, the base of my exponent becomes base of my log base 0.5 of 1/64 equals 204 over P. When you don't know, when the variable's on the bottom, you bring it up here, and you bring the entire log down. These swap spots. So I get P equals 204 divided by that entire log. They just swap spots. So let's type that in. If you have a fraction button, you should use it. You should get P equals 34 minutes. an initial mass of 50. So we know I equals 50. And then a half-life. And then it follows right after it. So what's the 20? P or T? T, because it follows right after. It has a half-life of 20 minutes. So every 20 minutes it's halving. It wants us to write an equation. So the catch here is I don't know T and I don't know F. And if I don't know them, they just want an equation. So I just fill in what I do know. Right? So we have F equals 50, 0.5, or they could use a half to the T divided by 20. And then here it wants what's the mass after 35 minutes. So we're just going to put that in for T. So we get F equals 50, 0.5 to the 35 over 20. You're packing up. I was like, you're a little early here, friend. I mean, really? What? Not true. I'll go grab them for you. Oh, awesome. Let's run out of paper. I'll fix it. So F equals, it should be less, and it is 14.9 milligrams. And then the last one says a culture starts at 3,000, so that's my initial. After 3 hours, does this come with halving, doubling, or anything? No, so that's my T. After 3 hours, it's estimated to have 48,000. What is the doubling period? So it's asking me for P because doubling is in the question, correct? Oh, no! If I don't take it from you, it looks like I'm playing favorites. This is how it works. I love you. You didn't give me a cookie, so that was... Just kidding, I'm at phone 5. I'm at 1/6 of the class.
Is this second question?
No. This will just come out as hours, so P will be hours. Yeah, whatever the one is, the other. If in the end I wanted minutes, I guess times it makes 60. All right. Okay, divide by 3,000. 16 equals 2 to the 3 over P. And 6, so then we go log base 2 of 16 equals 3 over P. If I don't know P, I swap them. So I get P equals 3 over log base 2 of 16, which is 3/4 of an hour. Or 0.75 hours.